Jeez. Sorry, I should be more serious here. Professor Peters.
Okay, I'd like to follow on some of the issues that Shuai raised, and while you're here, Tab, get your comments on this too. And this has to do with the kind of spinel seen at Sinus Aestium, which is a special case. And one of the observations about that area is, as you know, it's in a dark pyroclastic deposit. In earlier versions, we call these black spots, and all the previous data have always implied that these are very ilmenite rich. That's what gives them their low albedo. And in all the other pyroclastic deposits, such as at Apollo 17, the presence of abundant ilmenite masks almost any other feature there. So the Sinus Aestium is unusual in that you see these beautiful, strong spinel bands and no other mafic component. So from a spectroscopist's point of view, that implies either there's a whole lot of spinel, or that the spinels are large-grained and say a xenolith or something. So I'd like to hear comments from you, Tab, and any of the other geochemists in the audience of what the origin of that spinel might be, because it can't be just small crystals of 10% spinel. It has to be something very different, not to be masked by the ilmenite that's present.
Tab, before you answer that, does any geochemistry people in the audience or mineralogy have any comments? Okay, Tab, it's up to you.
All right, here's my big swing. So I think, so first off, the pyroclastic deposits at Sinus Aestium do not all exhibit the spinel spectral band. Maybe another point to make here, to David Kring's point about, are these endogenic processes that are forming spinel spectra that we can observe remotely, or is it more of an impact thing? Now we have spinel similar in composition to some of the MG spinel deposits, more iron rich and then debatably more chromium rich, probably more chromium rich, but maybe not exactly chromite, associated with very much igneous pyroclastic deposits. So in my opinion, it seems that there's a lot of evidence here supporting the igneous processes involved in spinel formation and what we can see remotely over the impact hypothesis. But to the point of these high titanium or potentially low titanium magmas, and at Sinus Aestium, I think we're probably safer guessing that it's high titanium system. You would actually, in addition to ilmenite, you would probably also expect oval spinel. So this is the iron titanium oxide variety. So it's very curious that we have such a strong spinel absorption as Carly suggests. So what's going on? My thinking is that during this magma wall rock interaction process, the diffusion speed of aluminum in these silicate melts, I made this point, is very slow. And so the contaminated region of a dike or an intrusion is going to be volumetrically minor, such that I will have, quote unquote, pristine areas of a melt to slightly contaminated areas of a melt to more contaminated areas of a melt to a highly contaminated area of a melt. And so I would actually expect during this process to see, deposits of aluminum-rich or, variety of spinel all the way down to maybe more of a chromite type of spinel. Now in the high titanium system, maybe I see both ilmenite, oval spinel, and then possibly in a highly contaminated region, I've forced that melt composition to be such that aluminum is dominating the partitioning into an oxide phase, that I could produce some of these spinels that are more chromium rich and more iron rich based on the Mg number of that magma to begin with. Does that make sense, or did I go on a too?
No, that's good. That's good. So, Clive Neal, you want to get, or Carly, did you have a Alvaverde?
No. Well, and this is probably, hopefully for Clive then, is that one of the things that I'm struck by, of course, these are pyroclastic, which means they're, if they're anywhere similar to our other pyroclastics, you know, they come from deep within the mantle, and in a volatile-driven, you know, the sorts of things that Jim has and Lionel have been modeling. And can these be mantle xenoliths? So let me leave that out there and ask Clive to answer.
Can I say something first? Clive, I want to make
Everybody's dribbling it around Clive and trying to get there.
Sorry. I want to make 2 points. First, the distribution. Jessica Sunshine several years ago using MCube data to do a mapping, and I also did a mapping myself, use MCube and multi-band imager calculator data. I feel it's quite widely spread all over the CNSS room. And some of them are higher, like such as freshly impacts craters, and some of them may be lower abundance. So it's kind of like a widespread, not just localized some spots. So this is not the same as the rest regions. This is one thing. The other thing, I do check the spectra very carefully. If you just look at the MG-rich spinel, you cannot reproduce the spectral feature we see at a CNSS room. You have to use other. Like especially the weak bands at shorter wavelengths, like a center around 0.5, 0.6-ish, you have to use chromium spinel.
Okay, over to Clive.
I think I've forgotten what I was going to say. So, oh, that's right. Yeah, mantle xenoliths. If you look at terrestrial mantle xenoliths, spinel peridotites have very low modal abundance. Spinel. You've got pixels that suggest you've got large outcrops of spinel, and I'm using all-encompassing. Chromite. It's probably Larry would kill me for saying that, but he's not here. But why can't it be a layered mafic intrusion? Because if you look at some of these big intrusions on Earth, you have chromite layers that stand out because they've been concentrated through igneous fractionation processes. You can't do it through impact. You can't do it by wall-rock interaction because you just don't get high enough abundance. But if you have these layered mafic intrusions, that's one way to concentrate it to the aerial extent that is now exposed. That gives you the signature with your...
Is it entrained in the pyroclastic on the way up?
So, yeah, where's the layered intrusion? Is it you have to have it shallow?
It could be entrained, or is it exposed in these crater walls because you've exposed the layered intrusion? I mean,
it's a mantling pyroclastic deposit,
if you're seeing it in pyroclastic deposits, then it's an early crystallizing phase. It's like you've got the olivines in the Apollo 17 orange glass. Well, you've either that or you've got a lot of little ones that are concentrated in one area through fire fountaining. So, but mantle xenoliths, the densities don't work. So.
Okay, Tab, I think we're going to be having to wrap this up in a minute or two, so let us have your, not penultimate, your ultimate comment on this, okay?
All right, the ultimate comment. So I would argue only one point there. I don't know if we can refute the layered mafic intrusion thing, and certainly if there were large magmatic events on the moon, that we probably did form something similar, very much to Clive's points. The one issue I would maybe also add to the melt rock reaction as far as how much spinel can I produce during this process, the limiting factor is the anorthositic crust. So if I have a reactive porous flow similar, or akin to a dunite channel on Earth, this process on the moon would instead form quote unquote spinel channels, I guess. And so as long as I have continued heat and pulses of magma that are reacting in porous flow through the anorthositic crust, I could form quite a bit of spinel in a highly concentrated area. And that will be another thing to investigate, in addition to some of these layered mafic intrusions. But with the layered mafic intrusion, I think you would expect chromite based on almost all of the terrestrial layered mafic intrusions, whereas you would need an extremely aluminum-rich system prior to crystallization to form pink spinel. And I do agree with Schwei's earlier points as well, that these spinel at Sinacearum are very different. And I didn't mean to suggest that there were localized deposits. They are widespread, but not every deposit is a spinel-bearing spectrum. I think the camera just fell over. I'm dead.
I think, no, we're good, we're good. So I think that was a signal from Yvonne that it's time to, call our discussion to a close. I want to thank everybody. This has really been an excellent discussion. So let's press on and move ourselves to the plenary session on international missions, which will be chaired by Greg Schmidt, and have our Korean colleagues tell us all about their program. Thank you very much.